right? So I started doing that, and here's what we ended up with. And this is cleaner than C++ iterators would be, but like, I was not happy with how much code it was. So we made a type that's like an iterator that goes over a bucket array, right? This is a polymorphic type, or what you would call a generic in C++, because it's got an argument. It's like the type of the thing. And then we have some functions. And the way it works is that the for loop knows to look for these functions if you're doing a for on a type that's not a number, right? So it calls iterator make at the start, which sets an iterator to the beginning. It calls iterator next, an iterator get value. And then if you call remove on the loop, then this is how you define what should happen in the array. And this all worked. We used this in production on the game for like 2 years, but I was really unhappy with it because here's the thing. All I was trying to do, in reality, anytime I wanted to iterate over a bucket array, is actually this following thing. It's a 2-level iteration. There's buckets, right, on the array, and then each bucket has some number of slots, and if that slot's not occupied, then skip. Otherwise, just put whatever code you would do here, right? That is all I wanted to do every time. And so in some sense, the job of a custom iterator for this data type is just to encapsulate this knowledge so that we don't have to remember how it works and type it out all the time and maybe get it wrong. The knowledge that it's actually a 2D iteration and you've got to check the occupied mask, right? Now, how does this turn into this, or even more code if it was in C++? So I was unhappy with that. And so I'd been thinking in the back of my mind, if we have a macro system, one thing I want to do with the macro system is just write a macro that says, here's how you iterate this thing. It looks like this. Right? And then your code just goes in there, and instead of having this giant thing with an extra data type, by the way, in addition to being more code, this is also slower because we have this extra data type representing an iterator, and you have to hope that that gets optimized out, which it probably won't in many circumstances. Yeah, it's a lot. Okay, so, this is what we actually want to do. That's all. And so I decided some time ago that this scheme of iterators would be unacceptable in the long term, but that we would just work with it for a while. So we did. Wow, everybody's loud down there. I might have to close the window. That's what I get for living in San Francisco. So, So we lived with this way for a while, but because this was such a headache, I didn't even make iterators for several data structures. So there's a hash table that I made, which was just a one-dimensional iteration, and where you would just check the hash, and hash value of 0 or 1 means unoccupied. And we would just do that manually every time, because I just didn't want to do all this stuff. All right, so that's the motivation. The motivation, well, among other things, of course, you want to be able to use macros for a lot of different purposes. But this was a concrete application that helped me understand whether I was meeting the goals or not, which is, can we just do this? That's all we want to do. We'll talk about the subtleties. It's not as easy as you might think. There are subtleties involved here. Okay. Now, leading into talking about macro features, we're going to actually not do a macro feature. This is a for loop feature, but it helps us plug into iterators later, right? So as people who have been following this programming language know, we have a very syntactically terse for loop, right? So here we've got an array of 3 strings called fruits. It's apple, banana, and cherry, right? A, B, C, fruit. And we iterate over that, and we're just printing 1 and then the item, right? And so that's all you have to do to iterate over a loop and do something. It's much less verbose than it is in some other programming languages. So if I run this, let's just go back up to the beginning. We're just going 1 apple, 1 banana, 1 cherry, right? And so that's what this is doing. And we have, for a very long time, had a syntactic way to reverse iteration on the loop, right? Which is just by putting this little less than in there, and then you go the other way. So for 2, we go cherry, banana, apple, right? The problem with that is it's only something that you can like type, which means it's a syntactic feature of your program, which means you can't like parameterize it. You can't have a parameter to a function that says if you want to go backwards or not without typing the loop twice and say if backwards do this one, otherwise do this one. And so there's always been a little bit of a disconnect there. So we added this feature where you can say, well, we're reversing or not, right? You can say less than, equal, and then that parameter, right? As opposed to just the less than here. And so here, fruits is going to go forward again. If I recompiled with this set to true, it would go backward. But we have a better example right here, which is here we have a function called print animals. We've changed to animals instead of fruits. We put a prefix in front, and then a compile time parameter that tells us whether we reverse or not, right? So this $sign means, again, when you call this with a constant, we bake the constant into the procedure and generate a separate procedure for each value of this parameter, right? So here we're going to print animals not reversing. So we're just going to go ABC with hello as the prefix. And here we're going to put sailor as the prefix. And we're going to do it in reverse order, right? So hello, ABC, sailor, CB, antelope. So that is an example of using this, right? Now this isn't a macro yet. This is just a regular procedure. Okay. Now, we also had this thing on for loop that's about whether you want to take the pointer to each element or not, which is very useful, you know, for if you want to be data oriented about things, you want to store things by value in memory as opposed to what a lot of modern, quote, modern, unquote languages encourage you to do, which is to have them separately heap allocated. And so you very often want to have arrays packed full of data. And then you want to iterate over independent things, and maybe you want to modify those things, or maybe you want to pass them somewhere else. It's convenient to have a pointer. So you can do the same thing. You know, the syntax before, I didn't have an example of it, but you would say star to say by pointer. And now you can say false or true. So we've got the numbers 1, 2, or 3. We're iterating them. And here we're iterating the values. And here we're iterating the pointers to those values. All right? And that's controllable by a parameter in the same way. And so then we've got this function that does both. We could say it's a for loop. Maybe it's by pointer or not. Maybe it's reversed or not. Iterating over these computers and printing the prefix and then whatever the value is of the thing that we're iterating, right? And so here I've made the prefix be the values of the variables. For F is for false in the first slot for not by pointer, and the second slot it's like not reversed, right? And so here we're printing the computers not by pointer, not reversed, right? Not by pointers and reversed, by pointers not reversed, by pointers reversed. Now these numbers are different from these numbers because we actually generated this procedure twice, and so we generated this array twice. And whereas we deduplicate individual strings right now, we don't deduplicate the actual array pointing to those strings right now. I don't know if that would ever make sense to do. But so those have different addresses because it's 2 instances of a function.